Welcome to today's deep dive. Our mission for you today is to explore the bizarre, fascinating world of Hericium erinaceus, which is better known as the lion's mane mushroom.
Right, but we're definitely skipping the dry taxonomy today.
Exactly. We're pulling from a stack of scientific reviews, cultivation guides, and ethnobotanical histories to zoom in on meditating mountain monks, 40-year-old fungi fighting nucleus cancer, and why this tree-dwelling mushroom tastes exactly like a lobster.
It is such a wild organism, you know. It fundamentally challenges what we assume about fungi, especially given its deeply intertwined human history.
Okay, let's unpack this, because the human side is just incredible.
Mm.
In Japan, they call it Yamabushitake, which translates roughly to the mountain priest mushroom.
Right, referring to the Yamabushi monks. They were this sect of hardcore ascetic Buddhist monks.
The ones doing those extreme wilderness practices, right?
Exactly. And they didn't just forage this mushroom. They actually actively brewed it into a tea to sustain intense focus during marathon solitary meditation sessions.
Wow. Deep in the mountains.
Yeah, just completely isolated, relying on this tea for mental clarity.
So it was effectively nature's original nootropic energy drink. I mean, that is wild. And the visual parallel is just brilliant, too.
Oh, you mean the jackets?
Yeah. It has this white, cascading, fluffy appearance that actually resembled the Suzukaki, those traditional fringe jackets worn by those very monks.
It is a perfect visual match. But if those monks were foraging for it, they weren't looking down on the forest floor.
They had to look straight up into the canopy, didn't they?
Way up. This mushroom grows 10 to 30 feet up in the air. It sprouts right out of the wombs of dead or dying hardwood trees like beech and oak.
And it doesn't even look like a normal mushroom.
Yeah.
No cap or gills, right?
Not at all. It drops its spores entirely from those exposed icicle-like spines.
So since it lacks that protective cap, how does it know it's safely outside the tree before it starts growing those vulnerable spines?
It literally measures carbon dioxide.
Wait, it measures CO2.
Uh-huh. Inside the dense, rotting wood, CO2 levels are incredibly high, often over 900 parts per million. Oh, wow.
So as long as it detects that high CO2, it assumes it's trapped. It grows in this tight, protective, coral-like mass. It only triggers the cascading spines when it reaches fresh air.
Wait, let me push back there. If a continuous fungal network is just sitting completely exposed on a tree trunk for, decades, how does it survive that long without mutating out of control?
That is the huge threat. A decades-old mycelial network faces a massive risk of what we call nucleus cancer.
Nucleus cancer.
Yeah. Because the network is continuous, a single mutated cheating nucleus that divides too fast could theoretically take over the entire organism.
Oh, so how does it stop that?
It uses a specialized structure called a clamp connection. It's essentially a genetic checkpoint at every single cell division.
Okay, so it's actively screening the cells.
Exactly.
Yeah.
It forces one nucleus to take a detour into a small hook-like branch and fuse with the cell behind it. If it's mutated and fails to cooperate,
Gets trapped in that dead-end compartment. You got it. The organism continually purges these mutated lineages, preventing cellular anarchy and allowing it to live for up to 40 years.
so it's effectively a 40-year-old genetic fortress. But here's where it gets really interesting to me. You'd think a 40-year-old tree beard would taste like bark.
Right, but it doesn't at all.
No, it has this uncanny seafood flavor. It's basically the crab stick of the forest.
The chemistry driving that is highly specific. The flavor comes from a volatile organic compound called 1-octanthreol, or mushroom alcohol.
And that's produced when you cut it, right?
Yes, the exact moment the fungal tissue is cut or crushed. But fascinatingly, this is the precise chemical isomer found in Australian prawns and sand lobsters.
Wait, really? A tree-dwelling fungus and a marine crustacean independently arrives at the exact same volatile chemistry.
The exact same one. It's a brilliant example of convergent evolution.
That is mind-boggling.
It really is. And ecologically, this specific scent profile creates a wild paradox in the forest. It acts as a potent attractant for biting mosquitoes, but it simultaneously repels Pacific Northwest banana slugs.
A tree fungus that draws in mosquitoes while warding off slugs with the scent of an ocean crustacean. The next time you see lion's mane, you'll know it's not just a trendy supplement for your brain.
Definitely not.
It's a mosquito-attracting, lobster-tasting, ancient monk tool that survives for decades by genetically editing itself.
Which brings up a final fascinating question to leave you with today.
Oh, let's hear it.
We always harvest and eat that beautiful, fluffy, fruiting body hanging from the tree, but while that part gets all the glory, the most potent brain-boosting compounds, the erinacines, are hidden exclusively within the sprawling underground mycelium inside the wood.
Oh, wow. Could the true treasure of this organism be the part we never even see? Something to chew on while you digest today's deep dive.